Okay, final question for tutorial chapter 8. A horizontal disk rotates about an axis which passes vertically through the center of the disk with angular velocity of 100 revolution per minute. And then a small particle of mass 10 gram is dropped onto the disk 9 centimeter from the axis and sticks to the disk. So if the angular velocity is reduced to 90 rpm, determine the moment of inertia of the disk about the axis. Okay, so again, for this type of questions, we know that the angular momentum is conserved. So we can actually apply that principle into this type of questions. So firstly, we have the information that we have is the angular velocity. So the initial angular velocity is equal to 100 revolution per minute, and then the final angular velocity is given as 90 rpm. So this one, you can convert this into radian per second, or you can mesti convert lah, just so that you don't forget that you have to convert this into SI unit lah. Okay, this is 10 over 3 pi radian per second. Sometimes I don't prefer to change it into decimal points because you will round off a few numbers, causing the answers to be somehow tidak sama lah jawapan dengan final answer. Okay, so if you can keep it this way, keep it in fractions lah, ataupun yang 3 pi ni 10 pi itu, keep it that way. Okay, so now we can use the conservation of angular momentum. Okay, so initially we only have the disk rotating on its own, so it's gonna be I d omega naught. Okay, and then after that ada a particle drop onto the disk. Okay, so when it is dropped onto the disk, we will have another particle lah yang we have to consider dia punya moment of inertia. So it will have the same final velocity, but we have to consider the moment of inertia lah. So it's gonna be the disk plus dengan the particle. Okay, so that is the after punya. Okay, if we were to draw this, if we have a disk macam ni, initially dia saja yang rotating. Okay, contohnya dia saja rotation dia begitulah. Okay, and then after that, tiba-tiba after ada pula particle drop. Okay, ada pula satu particle ni yang it is 9 cm from the rotation axis. Okay, so both of this will be rotating with the same angular velocity, tapi we have to find that value of angular velocity lah. So that's why we are going to use the conservation of angular momentum. Okay, so lepas tu dia ada bagi kan, dia tidak bagi pula particle. But if it's particle kan, kamu akan guna the moment of inertia punya equation to be mr square saja. Okay, so if we rearrange this, you can get the moment of inertia of the disk to be, after rearranging, kamu punya final equation should be something like this: omega over omega naught minus omega. Okay, so after rearrange, kamu akan dapat begini, which gives you the answers to be equal to 7.29 times 10 to the power of -4 kilogram meter square. Okay, so this part here, this one kamu change pergi, kamu punya value is mr square. Okay, so this is the moment of inertia for a particle. Okay, right, so that is basically the solution for question 10, which is the final questions in tutorial chapter 8.